ಯಾಕೆ ಬರ್ಬೋದದ ನಿಂದ್ರ ನೋಡು ಮೈಸೆಲ್ಫ್ನಾಗ but visible due to network problem. Okay, good morning. And message. Message, and then we talk regarding protocol. Okay, then the medium through which these messages are transmitted. So these are the components of our communication system, right? So how exactly we discussed all the details regarding these things in the last class. Okay, now we'll talk regarding the data, how exactly it will be represented. Okay, basically that whole arrangement is for transmission of data, and we need to see how exactly data will go to be represented on the medium. Okay, so we come across different kind of a data in data communication. Earlier most of the communication used to happen through text, and sometimes numbers also will be a part of the messages. Now you know that images, videos, audio are also a part of the data. Okay, so when it comes to multimedia messages, all these are part of the data, right? So now we'll see how exactly these different kinds of data are represented. Okay, in the end, when it comes to a representation, all will go to be represented by using a zeros and 1. Now first we should know how exactly, what kind of methodology they use to represent these data in the form of zeros and 1. Okay, so when it comes to a text, most popularly used representation is ASCII code representation. Okay, already you are aware regarding this ASCII code representation. So this is an ASCII code representation which will be, say, used when it comes to a representation of texts. Now again, I will not go into details of this ASCII representation. Most of you are aware it is actually 7-bit code, 127 characters are there. So this representation is very popularly used in the computers and all. Okay, so which will be helping us to convert the text to a zeros and 1 form. Basically this is, say, whenever you are writing a character A, it will go to be converted back into a zeros and 1 form with the help of this representation technique. Next is numbers. Okay, numbers too are represented by zeros and 1, but slightly a different methodology they use over here. Okay, so when I talk about 0 will go to be represented by 0, 1 will be so the numbers are slightly different, they are represented in a different way. Next is images. Next is images. One thing you keep it in the mind, for numbers we don't use say ASCII, but when it comes to images, as you know that image is made up of say pixels which are arranged in the form of matrix. Okay, we have a set of pixels, okay, which are in the form of a matrix, are basically used for representing the or creating the images. The pixel here indicates picture element. Okay, so every picture element will going to be represented by zeros and 1. And again, these pixels what we talk, okay, depending on the kind of image, the pixel values will change. Okay, when it comes to a black and white images I am talking, so these will go to be represented by only 1 bit pixel. Okay, either it will be 0 or it will be by 1. So say for simplicity reasons, okay, I'll say 0 is used for representing black, 1 is used for representing white. So these 2 bits basically helping us to represent a pixel color. Okay, so I mean actually only 1 bit, the 2 states of this bit. Okay, either it will be 0 or it will be 1, which is meant for representation of this pixel, whether it is a black pixel or a white pixel. To represent that, this representation is used. Again, when it comes to grayscale images, now see, okay, if you want more details about the say of some image, okay, you need to represent that image by using a more number of pixels, which will go to reveal more details. Okay, now say I will try to move from black and white to a say next category of images, that is grayscale images, where I will going to talk regarding representation of multiple shades. Okay, so normally in grayscale images we talk of using 256 different shades. How many? 256 different shades. Okay, so okay, the highest value is white. In between these two, black and white, two extremes, we have a different shades. Okay, so it starts from this and ends with all ones. Say for convenience reason I am using these notations. 0 means is easy to remember, so I am saying that 0 will be used to represent a black. Okay, now I am talking regarding grayscale image, and I am talking regarding 256 different shades. Starts with black, ends with white. Okay, so that means now it will decide, okay, these number of shades what we are talking, it will decide how many number of bits that are needed to represent each pixel. Okay, now when I talk about a pixel in a grayscale image, it will be represented by say 8 bits, because 8 bits can help me to get say 256 different values. Starts with 0, okay, goes up to 1. Yes, so in between you're going to have a different values which will represent a different shades. Say for example, if this is a next number, it will be slightly say lighter than dark, lighter than black, slightly light black. Okay, so if I talk about the next one, it will be slightly more lighter than this, and it's so on. It continues that way and goes up to white. Okay, so like this. So we have 256 different shades which will be represented by, okay, these bit patterns which are used to represent the pixels of the image. Okay, now every pixel will going to be represented here by 8 bits. Now the kind of a image we are talking, okay, what kind of a methodology we are using say in the image, or what kind of a image it is, whether it is a black and white or color or say grayscale image, depending on that the size of the images changes. So say for example, if your image is of the size 64 by 64, so as I said, images are represented by say matrix of pixels. Okay, 64 by 64 means, say, actually, so many number of pixels will go to be there. 64 into 64, whatever the value you get, that many number of pixels will go to be there. Okay. Now I said, say, rather than taking this large number, I take a smaller value so that I can show you the calculation. If my image is of the size 8 by 8, yes, so that means my image, total number of pixels that are present in my image is 64. Okay, total number of pixels that are present in my image is 64. So this is, say, matrix pattern in which your image is represented. So many number, total image contains 64 pixels. Okay, the number of pixels that are present, total number of pixels that are present in the image is 64. Okay, now if it is a grayscale image, you need to multiply this by 8. You need to multiply this by 8, which will going to give you number of bits that image is represented. How many number of bits that will going to generated, that many number of bits that will going to be generated by this image. How many number of bits that image will going to generate, that will be obtained by this. If it is a black and white kind of image, the number of bits that are generated by that image is 64. Now see, a small change. Okay, earlier it was black and white, say now it is a black and white. The number of bits that are needed for representing that image is 64. Clear? And if it is a grayscale image, you just see, it will going to be increased by 8 times. Okay, 8. 512 bits we need to represent a grayscale image of a same size. Now size of the image remains same. Okay, depending on whether it is a color, black and white or grayscale, the number of bits that are needed will change. Okay, so same way, similarly, when we talk regarding, say, color image, again, number of bits that are needed for representation of normal color image will go to be increased. Basically, the color images are formed because of 3 basic colors. Okay, we call them as RGB. Okay, so if I take that each color is getting represented by 8, okay, so you need to have so many number of pixels. Okay, so one thing you keep it in mind, as the representation pattern changes, okay, as this representation pattern changes, the number of bits that are needed for representation of image will going to change. Okay, depending on what type of a what kind of a say method you are using to represent the image, whether it is a black and white, color or grayscale. Okay, so in detail we will going to discuss regarding that in a later part of our, say, subject. Okay, in one of the topic we will going to discuss regarding this in the detail. Anyway, we are not interested in detailed discussion of an image, we are interested in audio. Okay, next is audio. Again, this audio will also going to be represented in the form of zeros and one. So most of you are aware, whenever we say audio, it will be a continuous signal. Okay, normally this kind of a signals will not going to represent any audio. Just for understanding reason, for simplicity reason, I have shown you a sine wave. But normally your, say, audio waves will be like this. Yes. No, they are a continuous one. Now issue is how to represent them in the form of zeros and one, because what we said at the beginning, audio is also going to be represented in the form of zeros and one. Okay, so normally these type of a continuous audio signals are getting converted into a digital form. We call it as a digitization process. Okay, so how exactly digitization happens? So digitization, a simple technique is sampling technique. Okay, take the samples of such kind of image, I mean signal, at different time intervals. I'll write it over here. I'll take a simple wave so that you can understand. Say I'll talk of this kind of a waveform. Okay. So as I said, sampling, what exactly the sampling? Say I'm going to divide. Actually, it is time versus amplitude graph of some signal. So on this line we are representing a time. On this axis we are representing an amplitude of a signal. Okay. Now what I am saying is, you divide this timeline into a small intervals of say equal size t1, t2, t3, t4, so on. So say this duration remains same. Okay. So duration between t1 and t2, duration, okay, it is same. So you divide at these intervals or at different time intervals like this. Okay. You are talking of taking the sample. Taking of sample means what? You are measuring this waveform amplitude at this time. Say at time t1, what is the value of amplitude? At time t2, what is the value of amplitude? Rather than going for continuous measurement of the amplitude of this signal, you are talking of say dividing this whole timeline into a small discrete units, and you are measuring the amplitudes at that time interval. Okay, this is what is first step of digitization. Okay, where we are talking of creating a discrete values of this continuous signal. Okay, since it is a continuous, it is very difficult to represent in the form of say digital form. It is impossible. Okay, so for that reason what we say is, we talk of dividing the given signals into a this way. We are discretizing it. Okay, so that means if you take a samples at different time intervals, your waveform will going to look like this now. Now see, at this time interval, the value of it is say some amplitude value. At this time, what is the amplitude value? That is shown over here. At this time, what is the amplitude value? You see, your continuous wave, now it got represented in this fashion. Okay, this is the first step that is involved in representing this audio in the form of digital. Again, the samples what we have collected at different time intervals, again they are of very wide range. Okay, so it is again difficult to represent them in the form of say digital form. For that reason, the one more step we use over here, that is quantization step. Quantization step is nothing but rounding off of these values. We will go to round off them. Okay, rather than taking a value as it is, we will go to round it off. Okay, that process of rounding off of these values, we call it as quantization. Okay, I am going to discuss how exactly quantization happens in the later part, but for time being, for understanding reasons, I am just telling you this thing. Okay, so once if you quantize these values, okay, so it is easy for these quantized values will going to be represented in the form of digital. So now what you did is, you are talking of say the signal which needed say infinite bits to represent values, which is practically not possible, that you converted it back to a say finite value representation, which is in the form of digital. Okay, it has a many advantages. Those advantages and all we'll going to discuss it later. So this is how your audio will going to be represented. Okay, one of such digitization technique I have discussed. There are some different techniques. Okay, we'll see to it in the later part. So this is how your audio will going to be represented, and the number of bits for each sample. Okay, number of bits for each sample entirely depends on quantization process. Okay, how many say quantization levels you are using, that will decide the number of bits for each sample. Say for example, if you are talking of say dividing this whole values into 256 different ranges. Okay, in that case you need to have a 8-bit value for each sample. Okay, again, how many levels or how many say different values you are planning to represent, that will decide the number of bits that are needed for each sample. Okay, so this is regarding audio. Next is video. So as you know that video means what it is? It is some series of images. Yes. So say for example, just to create that motion effect, I need a 30 frames per second. That means 30 different images we need to generate to give you that motion effect to the video. Okay. So that means we are talking of say generating 30 images in 1 second. Okay, so for a better quality video we need to generate a 30 frames. Here frame indicates frame is as good as one image only. Okay, so that means you are generating 30 frames. Okay, 30 images in 1 second. Okay, so continuously you are clicking these images and you are streaming them. Because of they are streaming at a faster rate, you get say feeling of that say motion in the video. Okay, so that means you are generating 30 images per second. Imagine what kind of what quantity of a data it will going to generate if your video is of the type color one. Okay, so that is the reason you see in mobiles and all your say video cameras are not using large number of pixels to represent a say they will be not be of the say of very large pixel values. Okay, most of the time they are of the type VGA quality. Yes, so this is how my different types of data that are used in a say data communication are represented. Okay, so these things we are going to discuss it in the detail in the later part. Okay, next is now we talked regarding the data. Now we'll talk regarding how exactly this data will flow from sender to a receiver. Okay, so that I am going to call it as data flow. Okay, so how exactly this generated data will flow from sender to receiver. Okay, so in earlier figure I used to say message over here. Yes, how exactly this message flows from sending side to a receiving side. Okay, while explaining a jitter, I said to you that this message gets converted into a small packets. Whole message will going to be represented by set of packets like this. Okay, so these will be moved from sending side to a receiving side. Okay, now we will talk regarding what are the different ways of data flow. Okay, now see, when it comes to a communication, we come across different scenarios. Okay, different kind of say ways of communication in a client server environment. Yes, most of you are already say aware regarding this client server because most of you are accessing the servers of different vendors. Okay, to get the services. Okay, to download your marks card you are accessing the video server. Okay, to know regarding some information you are say just dealing with some HTTP servers. Okay, like that there are some different ways of communication. Sometimes we use applications of the type say Skype, which is video telephony, where sender and receiver both they exchange the data. But whereas in client server environment you see what happens, sender requests and most of the data that comes from the receiver, the server will reply back to the request. The quantity of the reply that will coming from server to a say sender will be very large. In this type of a communication, lot of data is flowing from server side to a client side. Okay, and in say video telephony type of applications, data is flowing in both the directions. Okay, So depending on these type of applications and all, we have a different, say, categories of data flow. I talk regarding three basic data flow techniques. One is simplex. First one is simplex kind of a data flow. Okay. So what exactly the simplex means? Okay. So in this type of, say, communication, there will be only one designated sender and other one will be receiver. That means the flow of data is only in one direction. Okay, it is from sender to receiver. The job of this is all the time to receive it. Job of this is to send the data. There is no opposite direction data flow. Only in one direction data is allowed to flow. Okay, so this type of a data flow category, or this type of a category of applications where data is flowing from only one side, that we call it as simplex method or simplex mode. We call it as simplex mode of communication. Clear? Next one is half duplex. Okay, next one is half duplex. Next one is half duplex. Okay, what exactly a half duplex means? Please put some comments in the comment section whether my explanation is okay or not, so that I can understand, I can get a feedback. Here you can't speak and tell me a feedback. You can't give me a feedback by speaking. Okay, so please, in case if you had any doubts or some problems, that we'll go to discuss it later. But the quality of, say, video, yes, whether you are getting everything properly or not, that you tell me with the help of WhatsApp. Better you say send your messages in WhatsApp. Okay, already we have a, say, DC group where say 18 CS 46 DC group. You put your messages so that I can come to know, I can get a feedback regarding the class. Is it clear? Okay, please put a message saying okay, I will come to know. Is it okay? Please, all of you respond. I'm not getting any WhatsApp messages. Are you there or not? Okay, come back to this half duplex. Moment you are free, you just put one message saying that everything is okay, or if is there an issue, you just put some message in WhatsApp. Okay, half duplex, it is slightly different from simplex. If you club two simplexes, what happens? You are allowed to transmit in both the directions. Okay, in half duplex you are allowed to transmit in both the directions, but the thing is that only one is allowed to transmit at a time. Okay, so here both can, say, do the job of sending and receiving. Okay, both the parties, both the devices can send and receive, but when one is acting as a sender, other must be a receiver. This is what is the condition. Okay, I slightly change this naming. I'll call it as RS. Okay, receiver, sender, sender, receiver. When one is sending, other has to be a receiver, and when it is sending, the other has to be receiver. Okay, so that means data flow is allowed to happen in both the direction in this type of arrangement. Okay, so in this half duplex mode, okay, as I said, only one is allowed to transmit in one direction. Okay, next category, say, best example for this is walkie-talkie. Okay, whatever this police people they use to communicate with, say, everyone, Okay, that is walkie-talkie, where say one speaks and he completes his conversation by saying, say, stop or over, some kind of a indication he gives it to others so that they can start talking. Two parties are not allowed to talk there simultaneously. Okay, when one speaks, when he says over, the other one will start speaking. Okay, so this is walkie-talkie kind of a, say, arrangement. So this is, we call it as half duplex. Next is full duplex mode. Okay, next next category of data flow is full duplex. Okay, so in full duplex, the data flows in both the direction. Okay, simultaneously. So that means, just imagine, say, if I need, say, 1 gigabits per second for one link, in and all, I need a bandwidth of the medium should be of, say, 2 gigabits, because we are allowing the data to happen in both the directions. The given bandwidths get divided for two communications here. Okay, so this is what is a full duplex. Bandwidth and all those terms I am going to discuss it in the later part. For time being, just for understanding reason, I said that. Okay, so data flow happens in both the directions here simultaneously. Okay, anybody can send, anybody can receive. So that means it has to have both the capabilities. It should have a capability of switching from sending and receiving. Okay, so and it should capable to perform those two tasks simultaneously, both the parties. Okay, so this is what is meaning of full duplex. Okay, and next I talk regarding, say, the networks. Okay, first I will talk about, say, distributed processing. Yes, so most of you are aware what exactly the distributed processing is. Okay, so in distributed processing, say, actually the task will going to be get divided, say, among multiple, say, processes, and it will going to be performed on different separate computers. Okay, so where the given task, say, for you have some task, say, for understanding reason, I am representing it in the form of some, say, box and all. So I am going to divide this into three tasks, three smaller subunits, and these subunits will going to be taken care by different computers in a system. Okay, the first, you are distributing it to multiple computers, multiple will take care of processing these tasks. Okay, there are certain other issues. Many a times the task 2 requires a outcome of T1, task 3 may need a outcome of this T1 and T2, so that we call it as dependency, and there are some different techniques to overcome those problems and all. So right now we will not go into details. So this is what the given task gets divided into a smaller units, and it gets performed by multiple devices. Okay, so that to speed up the operations. Okay, so this we call it as, say, distributed processing. Okay, so next is, say, this is one small definition we need to know in networking. Okay, so again I talked regarding a distributed processing. Now I will define what is network. Okay, so network means it is a set of devices, okay, which are connected by some communication links. Okay, say group of autonomous systems which are connected together for the purpose of communication. Okay, so in this network we come across different terms such as node. Okay, so node here, okay, node here indicates sometimes computers. Okay, many a times it is printer. Okay, so any device that is capable of sending and receiving, we call it as node. Okay, so normally in the network arrangement, okay, usually we will have a kind of a distributed processing. Okay, so next, the two things we need to discuss, that is performance and say reliable security and reliability, which is in connection with your network. I'll just discuss it in the later part. Okay, so once I talk regarding the physical structures, then I will talk regarding those three definitions so that you can understand it better. Okay, first I will discuss regarding physical structures. These are all things you are already aware. Okay, so the first one is, in this physical structure I talk regarding the first kind of a structure, that is point to point. Okay, point to point structure. Basically I am talking of say dividing that creating that physical structure based on the connection. Okay, so first I talk regarding this classification in the form of physical structure. Okay, my battery of this phone is low, so that I'll connect. Okay, so that the physical structure, in this we'll talk regarding different types of say connection. Okay, so the connections are of the type point to point, connection. Okay, first I'll start with the point to point. The second one is multi-point, point to multi-point or point to multi-point kind of a connection. Next is broadcast type of a connection. Basically multi-point itself is a kind of a broadcast communication type of connection. So using these two connections, we're going to have a different kind of say physical structures or different kinds of physical topologies. So in point to point there will be two devices which are connected by using some dedicated link. Okay, next is point to multi-point. You see, I'm going to have multiple devices which are connected on the same medium. Okay, in point to point we talk of two devices are connected by a dedicated link. In multi-point type of a connection or arrangement, you're going to have multiple devices that are connected to a same medium. So that means in this type of arrangement the media will going to be shared. So that is the reason we call them as a broadcast kind of a medium. Okay, sometimes this is also kind of a called as broadcast arrangement, whereas it is point to point arrangement. Okay, so in this point to point the two devices are connected with a dedicated link. Okay, whereas in multi-point we talk of connecting all of them to a common link so that they can share say medium. Okay, so the medium resource, that is basically a bandwidth, it will going to be shared by everyone. Okay, so that is the reason whenever somebody transmits something, it will be visible to everyone, but only one will going to accept it. Okay, in multi-point arrangement the dedicated thing, like say whenever somebody sends a message, this message it is meant for some specific device, but still all the devices which are all connected to this medium will see this message. Okay, the arrangement will be so that they will go to reject that, only intended party will go to receive it. Okay, but the whole thing will going to be seen by everyone. So that is the reason we call it as broadcast kind of a say communication. But whereas in point to point, whatever the message you are throwing on some specific link, it will going to reach only specific receiver, not everyone will go to see it. Okay, so next one, next we will talk regarding say the topologies, basically which are formed because of these type of connections. Okay, either we use point to point or we use say multi-point type of a connections, which will lead to a different kinds of topologies. Okay, the first one I'll start, say, out of this. First I list the mesh type of a topology. Basic topologies I am talking. Okay, you may have topologies by clubbing all these basic things. Okay, different kind of topologies. Next one is star topology. Okay, so third one is bus topology. Last one is ring topology. Okay, way in which your devices are arranged or way in which your devices are connected. Okay, so based on that, this classification is done. Sometimes n1, it is not seen by -1. Okay, so if there are n nodes, n-1 connection for each, so that many number of, say, links you need in this whole system. Okay, is it clear? Okay, in case if it is a full duplex, you divide it by 2. That many number of connections you need. Okay, I hope it is clear to you all. Yes, so next, the advantage of this type of a topology will talk. There will be some dedicated bandwidth between two nodes that will not going to be shared by anyone. The quality of communication that is happening between two nodes will remain same because that bandwidth is not getting altered. It is not going to be shared by anyone. Okay, no competitors for it. Whatever the bandwidth that is reserved, it is meant for them. Okay, so that is the best thing of it. And when it comes to a security, since the link is dedicated only between two nodes, okay, the most secured way they can communicate. Yes, last part of it is the reliability. How reliable this kind of a systems are in case if one link fails. Okay, the only communication between those two nodes is getting disconnected, whereas the system still functions. Okay, it is more secure and it is more robust in nature because failure of one or two links will not going to affect the whole overall system. Only those few nodes will going to be affected by these type of failures. Okay, so still whole node will be in functioning. Major disadvantage. Okay, major disadvantage, you see, number of connections. You need huge number of connections. It is complicated to create that type of system as number of systems increases. If you have a smaller number of nodes arrangement, you can have this mesh topology, which will work better. But as the number of systems increases, more number, then it will go to create the problem. Okay, so this is what is disadvantage. Yes, cost. Yes, cost is again high because you need more links. Yes, cost is high, and when I say cost, mainly you need some kind of arrangement at node to support so many number of connections. As I said, it will not be suitable for large number of, say, environment system where more number of nodes are involved. Okay, if you increase the more number of nodes, what happens? Number of connection points what you need to provide on the system will going to be also increase. Okay, so that makes your system bulky. Clear? So these are certain issues or problems that are associated with mesh topology. For a smaller arrangement, it is very suitable. Okay, the biggest disadvantage is that you need more links and connectors, which will going to make system complicated. Okay, the one more major advantage is location of fault is very easy. Okay, very easy to locate the fault. Say if these two have some problem in communication, then only that problem is, say, in this link, not in other links. Fine. So isolating the problem is very easy in this type of arrangement. Okay, so this is what is a few advantages of mesh topologies. But all these advantages will going to be, say, will not be that useful when it comes to look at its disadvantage. Next is, I think you have one more class. Okay, so now it is 10:33. I will end the class over here. Okay, so star and other things I am going to discuss in the later part. Okay, say I am going to stop the discussion over here. Thank you very much.